In this video, we're going to look at evaluating limits using tables. So looking at this example here, we want to approach -1, and if we go to just plug in -1 to this function, we're going to get 0 on the top and 0 on the bottom. So 0 over 0 case actually tells me it's going to be a whole, so the limit is going to be a finite number. It's not going to be infinity, negative infinity, or it does not exist. I'm going to approach the same number from the left and the right. That's what that 0 over 0 tells me. It might be a fraction or a decimal, but it should be the same number on both sides. And it asks us to evaluate using tables. So I'm going to pick some x values to plug into this function. I'll just call the function f of x. What I'm really doing in my calculator is plugging into x squared plus x divided by x plus 1. And a lot of calculators need the top and bottom in parentheses in order for it to divide correctly. So I'm going to keep that in mind. And I'm going to do the left-hand limit to start. I'm going to get really close to the x value -1, but I'm going to come in on the left to see what that left-hand limit would be. So to the left of -1 would be even more in the negatives, like maybe -1.1. I'd grab my calculator, do -1.1 squared plus -1.1, and then divide that over -1.1 plus 1. So plugging into that original function, each x should be in parentheses, and then the top and bottom sheet should be in parentheses. So my y value is -1.1. I'm going to get even closer. I'm going to do -1.01, very close to -1. And the y value is also -1.01. And then lastly, we'll get super close. We'll do -1.001. And the y value is -1.001. So as x gets really close to -1, where we got an error in our calculator, you can't do 0 divided by 0. From the left-hand side, as we get closer to the x value -1, it looks like that left-hand limit is approaching, well, -1.1, -1.01, -1.001. That y value for the left-hand limit looks like it's approaching -1 for our left-hand limit. Let's do another table to compare on the right-hand side. Because we plugged in and got 0 over 0, we should get a whole. It should be approaching the same number from the left and the right, but there's a chance I plugged in wrong, and maybe it's not a whole. So let's double check that from the right-hand side, we're also approaching the same y value of -1. So I'm going to get close to -1, but on the right-hand side. So I can't plug in -1. That would give me an error. I'm going to come in on the right, and I'm going to get increasingly closer. So on the right-hand side, I could do -0.9, -0.99, and then -0.999. Super close to -1, but on the other side. So when you plug in -0.9, the y value is -0.9. When you plug in -0.99, you also get -0.99. All of these y values look like they're coming out to be the same as the x value. So as we get close to -1, but from the other side, the y value still looks like it's getting close to -1. So this limit, as x approaches -1, of x squared plus x over x plus 1. And there's so many ways to make these tables that are all correct. You can put the number that you're approaching at the top or the bottom. I try to show you both ways. It doesn't matter. You just want to see, as you get close to the x value you're interested in, what the y value is. From both sides, we're approaching -1 in the y value. So that means we just had like a hole in the graph, and from each side, we would have met at the same point. Both sides would go to a -1 y value. So that's our final answer for the limit.